Hello friends, welcome to massive open online course on data analytics. Now we are going to discuss on the part 3 of Unit 2 classification and clustering techniques. Part 3 involves remaining part of the unsupervised classification, performance evaluation of the classifiers and few case studies using R programming. Fuzzy Siemens clustering was first introduced by James Bezdek. It is an extension of the K-means clustering where one pattern is to assign in one cluster. But in case of Fuzzy Siemens clustering, where one pattern is to be classified in more than one cluster, and that is the situation of the overlapping clusters. So, the problem is addressed basically in terms of data ambiguity. By data ambiguity we mean a pattern belongs to a class with a grade of membership in the interval of 0 to 1. Fuzzy Siemens clustering is based on basically minimizing the following optimization function. The optimization function is mostly similar to the K-means clustering, but it is multiplied by a membership function of degree of fuzziness m. So, when E equals to double summation mu j I multiplied by the distance between the pattern and the centroid of the class. To start with the algorithm, step 1, we are going to choose the number of clusters C, let us say C, and minimum value to maximum capital N. Weighting exponent denoted by m is greater than 1. We initialize randomly a cluster membership matrix which is in the interval of 0 to 1. Each step of this algorithm is labeled R, where R equals to 0, 1, 2, it is a iteration. Now, we calculate the C fuzzy clusters which is denoted by Vj for the jth cluster at the Rth step, which is basically the weighted sum and respective ratios of the membership values obtained in the R minus 1 step and multiplied by the object value divided by the weights, sum of the weights. And step 3, we update the membership values. So, membership value j I indicates the membership value of the ith pattern into the jth class. So, what is the degree of membership of belongingness of a pattern I in the jth class? Step 4, we have to take the stopping criterion function, which is the difference between the current value of the membership function and the previous value of the membership function. If the difference is less than certain threshold epsilon, then we will stop, otherwise we will move to the next iteration for convergence. And the clustering decisions for ith data point are made by the maximizations. Wherever a pattern has the highest membership value, that particular class level will be, in that particular class, that unlabeled data will be clustered. Next, we are going to discuss performance evaluation. Every classifier needs to be evaluated when they are trained with a set of training data set. In view of this, confusion matrix plays very important role that shows the number of correct and incorrect predictions made by the classification model compared to the actual outcomes, which is target value in the data. So, the matrix, if you look at over here, we have the target positive and negative, and the models gives the positive and negative. Now, it not necessarily model always will give you the positive, which is actual positive. So, if that is so, that the matrix is 2 by 2 contingency matrix where you find A, B, C, D. So, A indicates basically the model predicted positive value out of target positive values, and that is called your true positive value, which is actual positive is predicted by the model as positive. Then true negative, the actual negative is predicted by the model as negative. False positive, the actual negative is predicted by the model as positive, and false negative, the actual positive is predicted by the model as negative. So, based on this, values we can compute the sensitivity and specificity of a model. Sensitivity indicates the true positive rate and specificity indicates the true negative rate. Ideally, both the sensitivity and specificity are expected to be higher for a classifier to be the most efficient and accurate, but in practice there may be the situation where sensitivity is higher, specificity tends to be lower. In this situation, it becomes very difficult to make decision about the superiority of the classifier. In view of this, ROC, that is receiver operating characteristic curve, has been introduced to balance the trade-off between sensitivity and specificity and finally generates a combined score based on which a decision can be taken that which classifier is the best. In this section, we are going to show you few case studies. First case study, application of Bayesian classification for predicting students' admission. There is a data set called admission data set, which is considered where a student's admission depends upon three features: GRE score, GPA score and rank, basically X1, X2, X3 features. And we have the model of Bayesian learning that has been trained. So, we have a set of codes using R programming has been shown in the yellow portion of this region, where a number of libraries have been called and the data sets, the programs have been written based on the libraries, where we can find that training of the Bayesian learning based on the supervised data available with us has effectively trained the model, and we are using for testing purpose few such instances given in the prediction part. So, in this table you can see that suppose first serial number 5, that is a unknown student, whether the student characterized by the GRE score 520, GPA 2.93 and ranked 4. So, whether he or she will get admission or not. If that is the question, Bayesian plays a good role. What you can see over there, it computes the posterior probability for admission class and posterior probability for non-admission class. So, for this student, the student's serial number 5, in this table you can see the posterior probability for the non-admission group is higher, that is 0.898 and so on, with respect to the value on the admission class, that is 0.101. So, that student will be classified in the class of admission, that means he or she will get the admission. Second study on the application of the SVM for iris data classification. Iris data set is very much well known and benchmark data set that contains 3 classes of total 150 instances each, where each class offers to a type of iris plant. So, there are 3 types of iris plants: setosa, versicolor and virginia, and there are 5 features which are based on which the data have been collected, and this data has been downloaded from the UCI machine learning repository. You can go through and find the details of the data, and by applying the the algorithm using R platform, we have got this diagram. You can see that 3 different plants have been classified by this SVM classifier and visually represented by 3 different colors, and that is the SVM classifications, how it can help to classify 3 classes. The next case study on application of the decision tree for reading skill classification. The dataset description is about a dataset built in R already, as reading skills is considered here to create a decision tree. It consists of 3 features: age, shoe size, score, on the basis of which someone's reading skill is classified using decision tree. So, from this tree generated by our programming, the inferencing is that from the decision tree we can conclude that anyone whose reading skill score is less than 38.3 and age is more than 6 is not a native speaker. Next case study on application of hierarchical clustering for US arrest dataset. All these datasets can be downloaded from the UCI machine learning database. Now, the data describes the US arrest information that provides the information about the attributes like murder, assault, okay, urban population, rape for 50 states during the crime investigation. Using this data, we can find states those of which are having similar crime profiles, and that's why a hierarchical classification technique has been introduced and a cluster dendrogram has been generated. And then from this dendrogram you can find there are, if you take the height, that is distance, proximity value 3, then you will get 4 different clusters marked by 4 different colors in the graph you can see. By applying k-means clustering, we can again classify the iris data. We have already used the iris data in the previous slide, you can see, and you can find from the scatter diagram 3 different colored dotted data points form 3 different clusters, and that is how the clustering, k-means clustering is also applicable. Now, we are applying the k nearest neighborhood classification technique for the same iris data, and where you can see the scatter plot, and after applying the k nearest neighbor classifications, we get a very nice classification based sets where 3 types of classes are betterly segregated and marked by 3 different colors, okay, and we are getting here accuracy around 95%, which is good. So, in this session I have shown you some classification techniques and few case studies based on which you will be able to understand in a better way. With this, I thank you all. To know more detail, you should see the e-content of this unit. Thank you very much.